Yeah, let me find a test that already gets close. There's nothing to drag here. It isn't close at all. Well, this one at least has. Oh, this is pretty close. I have a slider, an angle, and this can be. So I just have to actually multiple points. Yeah, let's use this one. Yeah, yup. Let's call this backtracking test or something. Call it backtrack check. Don't believe I need shapes. Why would I need a thread? Yeah, obviously, for that. Okay, so much for the headers. Entering main. Yeah, why not? Let's call this one then the backtrack check. Hey, King Billionaire. How is you? Guess any range will do. Might as well keep all these point. I need a point level. I need a level slider. Okay. Curve line style. I'm going to draw curves. Yes. A solid line. Well, maybe. Rectangle style. Let's comment it out. What is it called? P0 and P1? Well, why not? I can keep it that way. Just two draggable points. I have only 2 points, right? So I can remove this one. Create a point Q on the circle. Yeah. So some phi, some radius, and then the point. Create a point, second layer, point style, plot, p comma. Let's just put this one on 0. Make all points draggable. So, the register draggable, plot Q. Let's plot 0. And again. And then I want to have a slider. This slider is for the second derivative of the parabola, the third parameter of it. The coefficient of x squared, or w squared in this case. I'll call it C, because that's what I'm calling it in my readme. Draw a circle around P0. Plot circle, plot create circle, second layer, solid line style, blah blah blah. And that is again P0. Draw a label for P0 and P1. Draw an arrow from P0 to Q. Draw a label for Q. Is that necessary? A line through P0 and P comma. I don't think I need any lines here, right? Or maybe, I don't know, shall I draw a line between P0 and P1? You don't have gamma. Arrow. Store the velocity vectors as a vector. I think here it starts to deviate a bit too much. I do need a direction though. So let me delete this. Vector. I have a direction here, which is from Q to P comma. Yeah. Let's call this D0 simply. The rest has to do with Bezier curves, so I'll just delete it. I don't think I need eigen, so I'll just delete that for now. Nor symbolic for that matter. Oh, undefined type info with symbol. So I do need symbolic. For the quadratic energy, which is a standard part of. Okay, I guess we need it these days. Right, well that's close. So I have a P0 and a P1 and a slider. Slider is going a bit too much. That should go from maybe, I don't know, 0.02 or something. Let's say 1/10. Now it goes from -100 to +100. Right, well then we have to do calculations. I need to get my parabola out of this. To do this in terms of what I use in the readme. So we have a W0 value. Let's get all of it. W0. Here's my readme. This one. It's in machine learning source. So just 2 dots is enough. Do I want to get whatever W0 is? Double, call it W0 is, yeah, that then is the value of the x coordinate of p0. So I think that I can get that by doing plot p0. And then hopefully that works. Let's print it. And W0 is W0. Then it's -6, that looks correct. And then if I move it, I can move it to 10, -10. Yeah. Very good, we have our W0. And now get, which were LW0, W0 is, that would be the Y value at that point. Get W accent W0. Yeah, that would be the slope. So the tangent of the angle of the direction. We can just divide the x and y coordinates of the direction vector. It's just x and a y. If y is 0, or then it's x divided by y. That would be the tangent. Is that the slope? No. It's y divided by x. Yeah. So if x is 0, then the thing is vertical, which is not good. And then the slope is infinite. We can't have that. So that's good enough. I'm going to divide y by x or something. But maybe I should restrict this angle a little bit more. Where is it? Here's the restriction. Let's create a direction thing first, which basically is the same as the D0 that I created down below. And then I do if x is negative, then we change the x to positive. Why not? How do I do that? Can't assign it directly. I have to construct a new one. Is that even possible? You can do it like this. Construct from a single point. I can use 2 points. Yeah, if you do it, yeah. That's the one that's closest. I would like to call this wait, this is what I want. Not just change x, of course not. I just want to inverse it. And then we have the problem if x equals 0. I'm just going to construct it, I think, from, must be explicit, from a point, a single point, where I'll use 1/millionth as x coordinate, and then 1, almost 1 is the y coordinate. That always points up then, but yeah, who cares? I think this will work. So I have this thing and I should not be able to go past that point here. So it just jumps around. That is nice. Plus, yeah, you can't see it, but it just that completely vertical is not possible. no danger of dividing by 0 there, I think. Now, obviously, you can do the same thing for W1. We just not have a circle or derivative. I'm going to ignore that. Now, what else do I need? Let me think. And then a second derivative, which is just a slider value. How do I get a slider value? I would have no clue, of course. Let me try to get it from the slider. Create slider, it ends a slider. Yeah, just value. Suppose you can call slider value on slider C. Hello hearts. Let's see, this is sure, so I print this as well. So now you have everything. Right, to C. G can be changed, yay. P, that would be second half. And P0, of course. It's just all this also changes. Oh, that's if I do this, it looks like it points to that direction. Yeah, it's negative. Yeah, what? No, it's negative because it points the other way. Just not updated. Something wrong with dragging the center of something with an arrow. Just not updated correctly. So I'll just first have to position P0 somewhere correctly. That doesn't really matter, so I can just keep that a fixed point, put that there. And then play with the rest. That's gives less problems. Okay then, the next is that I want to draw the parabola. Why not? So the parabola is going to go through P0 and have the derivative according to this arrow, and the second derivative according to the slider. Let's fix this point here. It's minus 6, 4. Right, let me see. Parabola. Again, no idea how to draw the parabola, so I'll have to look at another function which does that. Test, I mean. I guess gradient descent does draw one. Parabola. Okay, it's just a KO window plot Bezier fitter thing. Might as well use it here. So yeah, so that can be assigned. Damn it. A different example. To the creative parabola outside of it. Maybe I should. first define the parabola and then this plots it. This returns points W and then the value of the parabola at that point. Then I have to create my quadratic polynomial, which just takes A, B, and C for this thing. Right, and then what is A and what is B? We know C because you have that little value. C is C. What is A and B? So I have parabola W is A plus BW plus CW squared. And I know that if we fill in W0, then we should get W0 plus CW0 squared. De derivative, yeah. The derivative is B plus 2C W0. That should be this one. And the double derivative is 2C. Oh, it's 2C. Huh? Yeah, whatever. My slide I see, so we don't talk about this one. In other words, here from this follows that B equals that value. Hello, Abhishek, new pane. Divided by? Why do you want to divide by anything? Just the 2CW on the other side. Then we have B. And after that we can conclude that A equals this value minus that stuff. The whatever thing, yeah. So double B is the derivative, that thing, minus 2.0 times C times W0. That was that formula here. And C equals A equals that value, this one, minus B times W0 plus C times, and I'm doing the utils square thingy, W0. Yes. That's it. That should hopefully be correct. It's a bit hard to check it, maybe. No, I think, yeah, no, you can see it, of course. It goes through the correct points and everything. And the derivative is correct. Just C is hard to check, I guess. Although at the moment C is 0, it must be a straight line. Yeah. The quadratic polynomial is defined in quadratic polynomial.h. Control T, I guess. 1G. Include. No problem. Oh, but no, it's right there. It stares us in the face. Yeah, this is the problem. It's a straight line because C is 0. So if I drag this, then it should just move along neatly. Perfect. Now let's go down here. And then change C. C is positive. Oh, no, it doesn't go through this point anymore. That's not good. It seems that with this scale, maybe the slider is not going up far enough. Let me go from -1 to +1. And seriously, it's just not going through the right point. Okay, slider. Slider goes from, that's a style. Let's make it from -1 to +1. And then go back to the formula here. Polynomial ABC, and that's the formula. And that should work, that code should work. So yeah, this one. You would say A is wrong because the offset is wrong. LW0 is the Y value of plot. That's where it should go through at the moment. Yeah, this looks good. So at the moment that w equals w0, then so w equals w0, then this part equals this part, and a, oh, I think I see it. There must be a minus here. Yeah. What is the problem? Try that again. Okay, so I want to point that down, and then now it works. Okay, yeah, I could want to test it with a maximum as well, but although I think it makes sense to test it with a minimum. That's what I'm going to use it for. Maybe I should make this C go from 0 here to... No, +1 is good enough, but it's another small fix here. Starting at 0 makes more sense. But now let's go to 1.5 then. So now I have a parabola, and the curvature is this, and then the derivative is set by this. It's always a minimum. Actually, I should not be able to drag P1 too far. P1 must be put in the vertex of this thing. To there. It will be there at all times. Yeah, so I think I have to restrict dragging P1. So I can only drag it up and down and not left and right. And then fix it at the vertex. So let's draw a dashed line as well through the vertex and P1. And then make sure that P1 is above the vertex. That I need the x-coordinate of the vertex, which I think is just given to me by the quadratic polynomial. Vertex x. Okay, so something with vertex x on the parabola. Let's see how that works. Create line. Create line, layer, line style, arguments. Fake. I'm afraid it's this one. Those arguments go to line. Okay, yeah, line. So a point in a direction would work. It's actually the only constructor that I have. Point direction. Well, the point is going to be this, and then we get the direction. The point is going to have this x coordinate and an arbitrary y coordinate, I don't care. And then this must be a direction, and well, up or down, I don't care either. I think my direction is up and down defined. But no matching member function for call to create a line. Cannot convert. Initialize a list. Oh, it just doesn't know what it is. Yeah, that's because we go through the stand forward stuff. So it has no clue that this has to fit the first argument of the line constructor. So we just have to tell it that it is a point. And still that doesn't work. What? Oh, that must be a line style. Oh. Got the line style. Let's use the same thing as we have here. Just line style. Arrow. Grid line. Line style. It's a dashed line, but yes. But yeah, now we have oops, a vertical line through the vertex, but P1 is not on top of it yet. So do that first. Next rather. I don't know what I want to capture. We're definitely getting a new position here. It takes a function that returns a point. That should already be known. So it knows that it is a point. I'm just going to return something like that. Now we use as x coordinate the old x coordinate. So that's P1 x and the y coordinate of the new position. can't type Y. And I'm not sure it knows what P1 is here. But well, it does, because I grab everything by reference. Okay. Let's be a little bit more explicit. I think that grab plot P1 by reference should work, because that has a lifetime that is completely outside of everything. Just the what is this, a main? What is this indentation? Oh, because of the try. Yeah, if you lose that, then there's a major error. Lose the indentation, lose the scope, go out of scope, go out of that scope. That's what I wanted to say. Why does it not compile? Cannot use the lambda return type, so nope, it's not that smart. Now you can specify the type here. Maybe boring, but that's strange. No, it's not strange. It's going to be a problem that with this C value we don't have vertex at all. Maybe we should start it at 0.3. And this should have a theta that is, I don't know, negative probably. Anyway, we'll try to drag P1. I cannot drag it horizontally anymore, just vertical. But I have to still put it on that thing. Let's make this start at 0.3. That is the slider again. It's a start value. I think I don't want to see 0 anymore here at all. Right, then so if the vertex moves, this depends only on W0. Yeah, so we don't have this yet. Not even that is necessary. Let's put that all the way down here. And also there and then. Okay, so now I want to set the y coordinate of P1 to, sorry, the x coordinate of P1 to the x coordinate of the vertex, again this. This thing is a point. It's not possible. Can only create a new point. Yeah, plot P1. Auto is probably just plot column column. It has been registered. No, I'm not so sure anymore. I can reassign it. Yeah, sure, I can reassign it. Sure, I can reassign it. No, I'm not sure at all, actually. Current point, anyways, returns. I guess this is in plot. I don't know if this is going to work. It feels like it should not work. Can only construct a plot point from a normal point. And anyway, if I do this, it will destroy this object. It's not what I want. Or is that what I want? Nah, not really. I think it will just disappear if I do this. Moved. I can call moved with a new position. Then it gets automatically updated, redrawn at the right thing. Yeah, this is what you call. You call moved and then pass a normal point together with a pointer to the plot. Thank God. Oh, I was going to say, thank God it is public. It is not. Well, I can change that, of course. But I can just call this. That one is public. How dirty can you get? Maybe we should make the other one public. I'm going to call moved. No, I might as well make this public then. Yeah, it disappeared. Label is still there, but oh no, actually it moved, but the label wasn't moved. I also have to move the label. This one is not draggable anymore. Oh, okay, that didn't work at all. It looks good, but the y coordinate is 0 and I can't drag it. So the line is not going through it anymore. Probably because this line is drawn first and then P1 is moved. That is not updated correctly. Yeah, I don't know. Damn it. I'll have to look into draggable to see how I can move it from the outside without screwing everything up. So we replace this with 2.0. Does it at least put it there? Bozo. Yep. Keeps it there as well. Damn it, I want to change this one. Just on negative value. Yeah, this is just updating the graphics. What is the reason that I can't drag it anymore? Because the point is not seen to be below this. Maybe if I just click on the window where I see it, then it doesn't think that the point is there, so there's nothing to drag. So normally it's called from here, moved. I'm doing the same thing here, it seems. I'm just calling moved. Create a new point and then call moved on the draggable. The class is just necessary to call the moved on the base class. But I made it public now, so I guess this works without as well. Is this the only moved in this function? Let's see if these two are defined. Oh, the begin's good. There's nothing that I can drag here. This one can be dragged. Well, is that the one that was moved or not? P comma. I have a Q here. Q is not draggable. P bad is draggable. Looks like only P bad and gamma are draggable here. Yeah, seems correct. So Q is not draggable. Was both are defined. These are draggable. And does it work? Because I'm calling moved on Q. Oh, yeah, okay. Yeah, nah. But yeah, Q is not draggable at all. It's not even registered as draggable then. Okay, so wow, this suddenly crashed. So just because I made this angle different, I think it was 5. Oh, sorry. Yeah, I think I meant quarter. Yeah, I think the reason is a little like this. It says register draggable at, and that it has this one. There's a y coordinate of 0 and an x coordinate of 2. That's where the thing starts. And now it's at -4 something 2, so they're completely different. You gotta wonder what happens if I click on that point that was registered to 0. Yeah. Yeah. I see it move. You see it move, but it's apparently it's immediately put back at where it is. But yeah, that's because I'm passing the constant. So change that back then. Truck. Yes. So that's all there is to it. It is not updating where it thinks that point is. So I can make a new member function called move instead of moved. And then make that work. Hey Louis, you are back. Well, that was 1.5 hours ago that I started. No, It's almost dinner time again. Yeah, I didn't miss much. In the end, it's just those few seconds that you actually see it work at the end, I guess. Draggable, I cannot find it anymore. It was called draggable with 2 G's, and that's what I'm searching for. And then we get, wasn't it like this thingy? Nope. Point is the one. And now it's called plot. Keep a copy, get the draggable by clickable index. You have draggable convert, which is the case, I think, for a point. It's not the case for the slider. To the point we do this, convert it to the actual coordinates or the point coordinates, and then create a new point, and then apply restrictions. More like if that function is set, I guess. If the function is set, then apply it. Yeah. And then call what I already call. There must be something else. Something before this is called, or after. Yeah, of course, it has to update, it has to keep track of the mouse coordinates of the pixel, of the point, I mean. Okay, so I definitely need to know the grep index of the point, and then we're gonna think further. That's stored in the draggable itself, which is public. Dus you can add a move here even. Now let's add it to the point. Point is derived, plot point is derived from draggable. And I'm going to add a move, and I think I need a plot anyway. By reference. It's a more user thingy. Let's keep this one private now. Index. Need it. Yeah. So I think I can do something like plot dot update draggable with the index, except it doesn't highlight. What was it called? Update grabbed. Well, we must be a window to call that. I think a batch can be multi-owned. Yep, up till 3 owners. So I can give this point, plot point, permission to call this. Let me first go to the header here. Point is a bit weird though. Maybe I should allow draggable to call it. Not all points are draggable. I guess draggable, oh, draggable is defined here. Even better. But then we have to do this in draggable, otherwise it wouldn't work. And what do I need from plot? Sorry, what do I need from point actually? I don't think anything. I don't think anything actually. Might as well move this to the base class then. New file. Oh. Still need to convert it, but let's start with this. Tja, so that is the inverse of what update grep does. What I really want is just not to do this in this call. Starting to wonder why this would work though. What is the difference at all? There's still no difference. There's still no difference. There's still no difference. Yo, I have to calculate the pixel coordinates because those must be stored. But they are not stored in this function. So, but yeah, definitely have to calculate them. So I do need to go through the inverse of this one. Maybe I have to duplicate this function. Well, yeah, almost duplicated. Not an update grabbed, but more like move grabbed. Just move the responsibility upstream to the plot here. So we make a new one. And I call this one move grabbed. Now this one can be called by draggable. And then this no longer. And then this is actually not pixels anymore, but just a point x and y, which I should pass as a point, I suppose. Yeah, like that. It doesn't have to be a new file anymore. Shit. Or we do, because plot is not defined yet. That plot is including draggable. Yep. Damn it. Damn it, damn it, damn it. Oops. Was it in plot? Of course it is in plot. Tja, really? We've grabbed How do we do the inverse of this? Right, now to store xy, which is now pixel coordinates, into wherever this thing stores it. That calls this. I bet it's called by window to bool if rectangle 2. Right, this is what we need to do. That determines where you can click to grab a point. which is part of window. Okay. Slightly confused. When is the geometry updated of a moved shape? No clue. No clue. Plus we don't have a window here, by the way. You know, this seems to indicate that this value that is returned here is the rectangle in pixel coordinates where the moved point, trackable as a point here, sits. So on the screen, so that if I click on that rectangle or square, is it, and it will know that I want to drag it again. Here it is restricted, so you try to drag it, and only here it knows where the real new position is. It's not where the mouse is, it's where this new position is. That new position is moved to this function, and then we return the pixel coordinates of the draggable. In other words, it should be updated by this function, the geometry. And I must have missed it, because moved is called on a point, for example. Okay, never mind. Yeah, it's totally updated. Okay. Okay. So after calling moved, we can call geometry. Which means that after this, I already have the geometry and I don't need to calculate pixels at all. What I need to do here is set this geometry to the array in window actually. What is draggable? So this one. So now I need to call something on the window, but I don't have window. I just looked, but it seems that plot doesn't even know which window it's part of. I couldn't find it. Is a point aware of that? window point. No, of course not. Point just has two doubles. But the plot point, no, this one, the draw object, so the draw point. Where is that? Here. Draw point is derived from a shape. And the shape has, this is the geometry. Shape derived from the layer region. Which has a pointer to a layer. Which has a window pointer. Ta-da! Ta-da-da-da-da-da. Okay. So the window is known. Call this on the layer. Call it on the layer call of the layer region. Which is part of shape, which is part of point. Now we're talking about draw point. So we need to get the draw point here. All I have is draggable. So I'm having a point here, which derives from the draggable, and that has a draw object. What we called moved. No, we did not call moved. I called move on draggable. So maybe I should call I'm gonna move this. I'll just put it in here. Yeah, and so now this must be allowed to be called by point, I guess. Like this well. Hopefully I'm getting the right pointer. It's probably plot pointer this way. This is plot point as well. It's kind of weird to me though that I have to pass a plot to begin with here. Here, I mean. Oh god, namespace plot. That's this. No, yes, yes. This thing has a drawn object. And it's private, but we are in point, so I can access it. That then is my draw point. Shared pointer to it. So again a point, but then in namespace draw. Which doesn't help me much, but that is it accesses the shape, gives me access to shape. It's just a base class. Which gives me access to layer region, which is just a base class. And the geometry. So geometry and layer, I can call on that. Layer returns a layer pointer. Layer is and then that layer was namespace Cairo window. It's just one layer. This has a window but not a plot. Nevertheless, I can get a window now. The geometry only is updated after calling this, so maybe I just should call that first, but I wanted to investigate if I can get a plot from one of these. Okay, that has to be done afterwards. I think a window has multiple plots. This is a window here. Clickable plots. By clickable index. So yes, I can get the plot because they are registered as well. My plot must have been registered under the clickable index. The thing is, of course, private. But okay, I can call a function on the window. Just imagine I call like update draggable. No, move must be move because it's also going to call that one. Move draggable, and then we just pass everything that that is going to need to know. I think I have absolutely every information here, except what window knows. So I can pass here whatever is needed, and then that will do the rest. So then I have a window here. So first of all, I need the index, the clickable index. Which is not highlighted because I put the thingy on the wrong side. There is a clickable index in draggable, which is the base class of this point. And then in window I can get a plot pointer from something called clickable plots. So this is called. Then I get the layer and the window, and then we go to the window itself, calling move draggable. Then we get here. That gets sent the plot, and then we call on the plot move draggable. All the time passing index. So this is no longer index. This is now the clickable index. And at that moment I could get the geometry after this returns. Because this function is doing this move draggable. This is no longer needed. This gets the draggable, although already have that down here. That is namely the point. Okay, let's just rename it. Apply restrictions. Pass this by reference. So draggable also has a geometry, which just calls. To see if we can find that back. Yeah, it's just this one. It's a vertical function of the base class of point. So we already have the geometry right there. And we are in window, finally. Now everything is done except for the header updates. That's a member function declarations. So my window has thought it was window. Please let it be window. Yeah, what? Duh. Click all rectangles. Poo poo. Great. And then this is plot.cxx. Oh, let's start with this one. Already called it. Unfindable. Thought I already called it apply. No. It's completely gone. Oh, there it is. And then point is plot point, right? Moved. Oh, wait a minute. That one already existed. I'll have a move though. What's this one? That wasn't changed. And this one doesn't exist yet. In window, move draggable. Is this public? Yeah, it's definitely not this. It's a point or the draggable itself, I think. No, it's a plot. Yeah. Moved plot point. Must be the plot. Oh shit, so I don't need a plot. What was it? Plot pointer? Nobody knows why, but it is a plot pointer. Plot pointer, plot. Yeah, that took a long time. I'm so going for a walk now and then make dinner. And it didn't work. Why? Oh, even crash better. But the F. So up on any redraw, I guess. And now it locked my everything. Just my mouse, I hope. Well, that's bad enough. Oop. It's a bit in the way. Let's try that again. The zigzag fold in. This is a nonsense pointer up. That is a point, or what was it? Standard vector. Standard function point. Nobody knows. Let's just go up. Yeah, that makes more sense. Oh, this is still a nonsense thing. Up. Print. Plot. Nonsense. Still don't have a mouse. Clickable index. That looks like pretty undefined. -1. Yeah, that should not work. On Y is clickable index undefined. Text underscore. And that is over the current object. The point object has no clickable index. Why? Print plot p1 with no index set. No sensible index anyway. Which is wholly unacceptable. Don't tell me that it's only assigned at the moment I start dragging. Nah. Register draggable. Plot queue, register draggable plot here. Break 73. Run. Index is 1. We have this trackable on the stack with an index of 1. And I would say isn't that this plot P1 then? Yep, that's the same. So at the moment, plot P1 does have an index. Pretty sure you can print it as well. Plot P1 dot base class index, or the value of the index, or the address of the value of the index. Then we set a watch point on that address, the contents of that address. Continue. And now it's fucked up again from 1 to -1 because Draggle is assigned. This is plot point, this is plot point, moved, point moved. How do I get in the moved? Do I call move, which calls move draggable, code that I just wrote? It's calls point moved, which then corrupts my index. Strange. If you look at the code, it makes sense, but then you wonder how can this have ever happened then? Worked before. Suppose I never really used that index then. But yeah, I think I found my draggable simply by looking in the array, and I only have a pointer to it, and that's enough. But you will have not stored it. What do I want to achieve with this line? Add point is just recreating the draw object and drawing it. So this then sets the new coordinates, I guess, completely ignoring that draggable also has a certain values to preserve. add point is updating plot point, right? No, it's, well, I think it is, even though it's passed as a const reference. Yeah, just assigning to it. I think the draw object is immutable, so it can be assigned. Right. Yep. So I get the value of this base class, and then well, then this is assigned anyway. That's the only thing. And then the whole thing is assigned to something else. Or oh, this is a plot point, sorry. So I make an empty plot point constructed from the base class thing. Yeah. That's this constructor. That then leaves this null pointer and draggable undefined. And then define this by calling this function. And then the whole thing is, which is still a plot point, is assigned to the current object, which then overrides unintentionally the value inside the base class draggable. Which means only the index. So what I could do is then call setIndex afterwards on it. Is there a better way to do this? Hello, Fortune. Seems that a better way to do is just assign a new position to the current object. Then call this and then call it a day. That should work. Yeah, it should work. I think that's, yeah, I don't know. Seems to make more sense. So we don't do this. And we use the current object. And then here I must assign the new position values to the current object, which is trivial because we are inside that object. Well, not too trivial because it's a base class image. probably. Well, I can fix it by make this protected or fix it. Yes. Or just assign, use the assignment operator maybe for the base class only. Yep, so new possession must be assigned to the base class. And then I want this to be the assignment operator of the base class. Which means that we have to do some kind of cast probably. Because static cast will do of something and then assign that. Where this and of course must be that base class. And it must be mutable. And then this is simply this. So we cast this to the base class and then assign it. That should only change the base class then. It works. That is, it doesn't crash anymore. So the index is now preserved. But P1 is now not updated anymore. Why? Or maybe it is updated but then put back immediately. Still drag it. Dragging works. I can only drag it vertically, and this updates a parabola, and this too. But P1 is not put on the vertex. Why? It's a complete failure. I'm going for a walk, I think. Because if I wait half an hour more, then the sun is completely gone. Plus it's 7 PM, so I should have been eating an hour ago. Unfortunately, now I will walk slowly through the neighborhood, being all depressed, instead of jumping happily around because I got my program to work. But I guess I'll have to do that later this evening. Thanks for keeping me company, people.